Good morning, miss.
Hi. Okay, we reached here last time, so we continue. From the previous example, we started with f equals a plus b bar c. We ended up with the following minterms, which is sigma of m1, m4, m5, m6, and m7. What are these? These are the locations where you actually have output 1 in f. Okay, so when you are listing them, you have to say f, you open the parentheses, you write the variables that you are discussing. So here in this case, we have a, b, c, so 3 variables. So how many combinations if you have 3 variables? We actually have 8 combinations because 2 to the power 3 is equal to 8. I write sigma m because I am adding the sum of minterms. This is why I put sigma m. And sigma m will be 1, comma 4, comma 5, comma 6, comma 7. So you could write it this way, m1 plus m4 plus m5 plus m6 plus m7, or you could write sigma m and you write between parentheses the terms that have actually 1 as output. Okay? We show the standard variables in order and drop the m designator. You write outside the m, you simply write here between parentheses what minterms numbers have actually 1. The complement of the yes, please.
ليش ما بنكتب 2 is 3 1
Which one?
1 4 5 6 7.
We did 1 4 5 6 7.
Yes.
Why didn't we write 0
1 2 3?
Yes.
ليش قفينا؟
Why we missed the 0 2 and 3? Because they have output 0. You only list what has output here 1. Okay, so by checking the function,
Thank you.
so you check here where do you have ones in your output. Notice here, please. You have here 1, and here 1. So how would you write this? Let me write it here for you so you see it next to the table. You write f equals sigma m, you open parentheses, and you have 1, comma 4, comma 7. See, so you only list where you have ones. You don't list the zeros. Okay, so this is why here I listed where I have the ones only. So 1, 4, 5, 6, 7 is where I have the ones. The 0, 2, 3 is where I have my zeros. So I only list the values that have 1 in the output. Okay. The complement of a function expressed as sum of minterms. When I say sum of minterms, it means I have to write sigma m. Okay, when I write the product of max terms, it is pi of big M. Okay, minterms is small m, max terms is big M, sum is the sigma, product is the pi. Okay, we want to go back to De Morgan's law where we said that if you do m minterm bar, you get the max term. When you do big M bar, you get the minterm. So this is exactly the same here. So you have here f of x, y, z. This is telling me that I have 3 variables that I am listing the output for, equals sigma m1357. This is where I have my ones. It is equal to pi of big M 0246. What does this say? 0246. This is where I have my
zeros.
Perfect. This is where I have my zeros. Okay. If I want to find f bar, so it is actually the complement of f. Okay, how do you write it? It is the complement of where 1357 I have ones. Now I want to do the complement. It is 0246 now is where I have my complement, my ones. And in pi of big M 0246, it is going to be pi of big M 1357. This is of course f bar, the complement of f. Okay, clear? To convert between sum of minterms and product of max terms or vice versa, you have to follow the following steps. Let's say you want the f equals xyz equals sigma m 1357. You form the complement by writing f bar xyz equals sigma m. You check here, where do you have ones? You write the complement, okay, of it. So here now, 1, 3, 5, 7, I have ones, and 0, 2, 4, 6, I have the zeros. When you complement f bar, you will have your ones now in 0, 2, 4, 6, okay? You use the other form with the same indices. This forms the complement. So f of xyz is equal to pi of big M 0, 2, 4, 6, because this tells me where I have, this tells me where I have my zeros.
Where I have my zeros.
Exactly. Okay. Let's do an example. A simplification example. We have f of ABC equals sigma m 1, 4, 5, 6. What are these, Ray? Yes.
Where I have my ones.
Ones. Oh, sorry, ones.
Very good.
Small m.
Very good. Where I have my ones. Okay. Let's go back now. If I want to write the minterms, okay, as a logical expression. So I have here my one. What is the one? It is actually 0, 0, 1. Remember? Okay. So 0, 0, 1 will be A bar, B bar, C. Okay. Now number 4. Yes, your help, please. Number 4. How do I write it? It is. How do you write number
It's
4?
1, 0, 0.
1, 0, 0. So it is A, B bar, C bar. You agree? Number 5, please. How do I write minterm 5?
1, 0.
It's 1, 0, 1.
0, 1. Okay. And how do I write number 6? It is 1,
1, 1, 0.
1, 0. And number 7 is 1, 1, 1.
1, 1.
Did you see it? So this is how you write it in sum sigma m, or you write it in sum of minterms. Okay? So let's go now and simplify this expression. I want someone to tell me, please, the number of literals in this expression. Number of literals.
12.
It is 12, no? Okay, it is actually 12. So when you are counting here, 1, 2, 3, you have to think of every literal here, A, B bar, C bar, and then A into B, C, you see? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you actually have 12. Okay, what happens, please? Yes?
Shouldn't it be 15 since A is a common factor?
It is, but if you want, you actually do the whole thing this once, and then you do it times A once.
Oh, okay.
Okay, so you do one more, and the result you do and with an A.
Okay.
Because if you do it like you are saying, it's going to be A, B bar, C bar plus, A, B, C bar plus, A, B bar, C plus, A, B, C, you will have more literals. Okay? I want someone to tell me what happened, please, from this step to the next step. Anyone?
Yes.
What happened?
Okay, so
Distribution.
It is distribution, yes. And we took B bar plus B into C bar plus C. What is this, please? Which identity is this?
B bar plus B equals to 1.
Very good. And C bar plus C is equal
bar
also
plus
to
C.
1. And 1 times 1 is, of course, a 1. So this is how we reached here. Now what, please? What can you say now? What happened? Who can help? It is no one?
8 times A
Can you repeat?
فأضلت مثل ما هي.
Can you repeat? I didn't hear you clearly, please.
Last statement is A times 1 times 1. It's A.
Yes, yes. I want from here to here. What can we do?
Oh, okay.
Yes.
Uh,
It is distribution if you look at it.
we can take A as a common factor or no?
No, no, no. One is A, one is A prime. Okay, I'll show you.
A
A
bar A.
plus A bar
Yes.
into A.
After BC plus A.
Did you see
B
it?
plus B bar plus
No,
A.
no, this is distributive law. First plus second, first plus third. See?
Yes.
Did you see it?
Doctor, I didn't understand it.
This
Can you
is
please explain?
distributive. This is distributive law. Okay. So you take A plus A prime and A plus B bar C. So you consider B bar C as if it is one value. So you take first plus second into first plus third, as if you have A plus XY, let's say. How do you do it when you have A plus XY? Let me write it here. A plus XY. It is equal A plus X into A plus Y. Did you see it? So now A bar BC, we consider it to be one term, and we divided it A plus A prime into A plus B bar E prime C. Is it clearer? That's the distributive law, okay? What is A plus A prime? Of course it is 1. So I am left with A plus B bar C. How many literals do I have here?
3.
Yes. So you have 3 literals as compared to 15. How come they said 15, not 12? As I explained earlier, they used A many times. So A, B bar, C bar, like I listed for Karnaugh. Okay? Clear? Let me look at this logic diagram. And I want you to check the 2 implementations for F. And I want you to see how apparent it is that the simplified one is, of course, simpler, right? So this is the one that they were doing, A, B bar, C. This is the original before being simplified. And then they did A, B bar, C bar. So this is an AND. This is also an AND. The output of the 5 ANDs will be ORed, and you get the F, right? What about the second one? It is A or B bar C. So you do the AND for B bar C, and the output of it, you OR it with an A, you get an F. These two are equivalent, but it is simplified. Notice the number of literals, please. Here you have 15, and there you have 3 only. Okay, literals. Okay. Now, when you are doing optimization, the goal is to reach the simplest implementation. Okay, you need to know that K-maps, they actually help you reach the simplest. Optimization is a more formal approach. You could simplify it using Boolean expressions or Boolean identities if you want, or you could optimize them using, as I said, K-maps. Optimization requires a cost criteria to measure the simplicity. You need to understand now the difference between the cost criteria. We have L, which is literal cost. I just listed it for you. I'll introduce 2 now, which is gate input, G, and gate input cost with not, GN. Okay? So we will follow now. How do we count the L? You already know how to count the L. We will see now how to count the G and the GN. Okay? If I want now to count, please, I need your help. How many literals is the first? Of course, it is written 8, but tell me, how did you count it to be 8? Yes, please? Anyone? How did we get 8?
Plus A.
Let me count it with you.
We counted.
1, 2, 3, 4, 5, 6, 7, 8. You simply count the variables. Okay, that's the 8. And here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. Which is the best solution? Of course, the number with the minimum literals. Okay, clear? Okay, now we check gate input cost, or G and GN. Okay, look how you count the G. You count the G by telling me how many inputs do you have to the gate. Okay, so here you have one AND. Be careful. How many inputs do you have to the AND? 2. Here you have an AND gate. How many inputs do you have to the AND gate?
3.
3. Here you have another AND gate. How many inputs do you have to it?
3.
Also 3. But The output of the AND gate and this AND gate and this AND gate are inputs to an OR gate. Do you agree?
Yes.
Yes? So also I have 3. So this is how you count your G. I will go over it in detail here, so pay attention. This is an AND gate. How many inputs does it have? 1, 2. You agree? And here,
Yeah.
1, 2. So look how we count them, please. 1, 2, 1, 2. And here you have an additional one, which is here, the A. Okay, so you actually have 5 literals. 1, 2, 3, 4, 5. You agree? 5 literals.
Yes.
Now what's the G? G is going to be 1, 2, 3, 4, 5, 6, 7. So this is my G. Is G clear? What am I really counting? I am counting the gate input. So I have this gate. How many inputs does it have? 1, 2. This is another gate, 1, 2. And this is a third gate, 1, 2, 3. So 2 plus 2 plus 3 will give me 7. Clear? How would we get Gn? In addition to G, I count how many not inverters do I have. So I have here 1, 2. So I add 2 to it.
So 9.
9. Yes, exactly. So this is L5, G7, Gn9. So L is the literal count. G is the gate input count. You add also the OR gate, because after you get the output of the AND, they will be input to an OR gate. Okay? And then you add the inverter input to calculate the Gn, which is with the NOT. Okay?
Doctor, can you please repeat?
Yes. This is an AND gate. Let me go with the literal first. Literal, count them. 1, 2, 3, 4, 5. Any difficulty? This is number of literals. L equal to 5. Now the new
Yes.
thing is we want to count the gate input. So this is a gate. You agree? It's an AND gate. How many wires does it have going as input into it? You have 2. So here you have 2 gate inputs. Here you have also 2 gate inputs. And here you have 1, 2, 3 gate inputs to the OR. As a total, 2 plus 2 plus 3 will give me a 7. So G is equal to 7. Okay?
Yes.
What do I add to the Gn? I found the G. What do I do to add, to find the Gn now? What should I add?
The NOT.
If I have not, okay, not inverters. So this is a not inverter, this is another not inverter. So I used in this circuit 2 not inverters. So I do plus 2, G plus 2. Okay?
Okay. Thank you.
So this is how you compare the costs for one circuit as compared to the other. Okay? So I want you now to look at this. This is ABC plus A bar B bar C bar. So this is it. And look at the literals. Who can help? How many literals do I have here?
6.
How did you count them? 1, 2, 3, 4, 5, 6. Okay? I want now to find G. Can you help please with G? I have here an AND gate.
It's 8.
Yes, but I want to go step by step. I have here an AND gate. How many inputs does it have?
3.
3.
3.
And here another AND gate. How many inputs does it have? Also 3.
3.
The output of this AND gate and the output of this AND gate will be the input to the OR gate. You agree? So 3 plus 3
Plus 3 plus 2.
will give me an 8. You got the idea?
Yes.
How did I move from 8 to 11 now, please?
I have 3 notes.
Very good. I have 3 NOT gates, so I add 3 to it, it will become 11. Okay? Now, I want you to look at the same function, exactly same function, but I implemented, so this is ABC, okay? It is A plus C bar into B bar plus C into A bar plus B. So these are exactly the same, but it is same literal cost, but you have 2 circuits for it. I want you now to count the G. How would you count the G? So 2, 4, 6, and 3, 9. You agree? G equal to 9. Can you count them now quickly with me, or you did not get the idea? I am ready to repeat if you did not get how do we calculate G. Anyone needs me to repeat, or you got G? How did I reach Gn equal to 12? Yes, please. George, what?
3 knots.
Yes, you have 3
9
knots. Yes.
3 knots. 3 to 9.
Exactly. Okay, you add 3 to the 9, you will get a 12. Okay. So, which is a better cost, do you think? Which is a better? Yes.
With the first one?
Yes, the first has better cost because you have better gate input, right?
Better what, miss?
Yes, please.
Better what, you said?
A better cost. Okay, it's more cost effective. Yani here you are using less gate. Okay.
Yeah.
What is a K-map? K-map is a collection of squares, and each square represents a minterm. And you have here the collection of squares is a graphical representation. Let me show you. It's easier to understand with the figure. Okay. Let me draw it for you here on the side. So this is a 2 by 2 K-map. You divide it into a square. And you write here, let's say you have x, y. So this is your x, this is your y. So 0, 1, 0, 1. Okay? Question. What is this minterm, guys? Look at the x, look at the y. It is zero.
مسكين عم بقطش فيك تعيد السؤال please.
Yes, I will. What is this cell? What minterm is it?
0.
Very good. How do you refer to it? It is 0, 0. You agree? How about this, please?
Yes.
Always start with the x first. Yes, please. What is this? It is 0, 1. So
1.
minterm 1. How about this, please?
1 0.
Yes, and this will be
1
1, 1. Okay? Clear? Okay. So if this is the
دكتور
yes, please.
دكتور انا ما فهمت اللي بالزاويه الشمال تحت. ما فهمت ليه قريت 1 0 مش 0 1.
You always start with the x. As I said, you always start with the x. So this is 0, 0, and this is 0, 1. This is 1, 0, because this is my 1, this is my 0. I always start with the x, and this will be 1, 1. Did you see it? Not yet?
Not yet.
Yes, I will repeat it for you. We will draw it again. Okay? This is a K-map. You divide it into 4, right? It has 4 minterms. I start with the x always here. Yani first variable should be always here, and the second variable should be here. X can take 2 values, either a 0 or a 1. Do you agree? And y can take 2 values, either a 0 or a 1, right? So this cell here is going to be 0, 0. Now you tell me, what is this cell? Start with x.
It's 0 1.
Very good. What about now? Start with x.
If I start with okay, so it's a 1 where I'm at. So where I'm at, it's 1 and 0.
Yes. What about here?
It's 1 and 1.
Yes, that's it. Always start with x. We always start
Okay, so
with x.
I always start with x. I always start with x, depending on which corner I'm at or which square I'm
You
at.
check the cell. Check the cell. This is the cell we are looking at. My x is 1, my
Okay.
y is 1, so this is cell M3. Okay, this is the third.
Okay. Now I get it.
You want me to repeat? Anyone else, please, or it is clear? This is the K-map. Okay,
Doctor.
this is a 2-variable K-map because I have only 2 variables. Yes, any other question, guys?
Me, please.
Yes, what do you want? You want me to repeat again?
No, I have a question here in the K map. Yani we should multiply them or add
No, don't worry. I'm still introducing. Just understand their locations now. Did you get
okay.
the locations?
Yes, I did.
Yes, just get the locations now, okay? Anyone wants me to explain the locations again before I continue? Why do I need the K-maps? Okay, we will move now to the truth table, okay? So very quickly, please, if this is 0, 0, which minterm is this? You agree?
0.
And this
Yes.
is M1, M2, and M3. Following? If you look at the K-map, A will be M0. You agree? And this is going to be M1, M2, M3. Okay? Are the locations clear? So I have here only two values. Okay? And when I know their locations, next I'm not going to count them. Okay, I just fill in the truth table in it. Okay, so let me show you now what do I mean. I have a truth table, okay, and the truth table in this case is xy bar and xy. I need someone to help me in the truth table, please. So xy and f. How do I quickly fill the truth table? Anyone?
0, 0, 1, 1, 0, 1, 0, 1.
Where are my ones, please?
Last one.
Only you have two.
لما يكون x y بار بتكون 1 ولما يكون x y بتكون 1.
Where يعني? How do I fill my f?
يعني على ال1 بنحط 1.
1.
Do you agree? Did you all see how did I fill the expression in the truth table? This is very important. Did you all see it? I'm ready to repeat as many times as you want, but you have to understand how do I move from a Boolean expression to a truth table to a K-map? Is it
Yes, please, can you repeat?
question? Okay, I am repeating, please. Make sure you understand. How many variables do I have? Two variables. You agree? The two variables have 2 to the power 2 cases, which is 4 combinations. What are these combinations? You have 0, 0, 1, 1, 0, 1, 0, 1. This is the only way to fill the truth table. Don't go and think about it. Just fill it. 0, 0, 1, 1, 0, 1, 0, 1. Okay? I have now 4 minterms. What are they? M0, M1, M2, M3. You agree? 4 minterms. What is the first minterm? It is 0, 0, which is actually x bar, y bar. Do I have it here? Who asked me to repeat?
No.
No, we don't have it.
Here we don't have it, so it's a 0. Okay? How about the 0, 1? It is x bar, y. Do I have it here? No, it's a 0. How about, what is this minterm? Haida, the one that you are seeing here, what is it? It is x.
XY bar.
Do I
bar.
have it here?
Yes.
Yes, so it's a 1. You got the idea, and of course I have 1, 1. Is it clearer?
Yes, I understand. Thanks.
Okay, fine. What did we do now? We did, so this is F. We did move from the Boolean expression to the truth table. Now what? I want to move from the truth table to the K-map. Okay? So this is M0, M1, M2, and M3, right? Tell me please in the K-map, where is M0? Yes, please?
The first one on the left.
This. You agree? Why? Because x is 0 and y is 0, so this is M00. Who can tell me now where is...
Doctor, can you repeat that question, please?
Yes, I was saying where is M0 in the table? M0, يعني minterm 0. Minterm 0. I mean by minterm 0, x bar, y bar, which is actually 0, 0. Right? So where is now M0? Which cell? I have 4 cells.
X0, Y0.
This, right?
Yes.
Maria, did you see it?
Yes, doctor.
Okay, you tell me now, where is M2?
One on the right.
Okay, M2 is 1, 0. So it's XY bar. So it's the one to the right on the bottom.
يعني
To the
here?
left.
Is this?
Yeah.
Yes, I agree. Okay, clear? Did you get it, please? How do I move from Boolean expression to K-map? Okay, why are we doing this? Look very carefully now. I take two adjacent cells that contain 1 in them, and I do this. Okay, I only look at the ones. I don't look at the zeros. I only look at the ones. So I have two adjacent ones. Okay? When I say two adjacent ones, I want now to look at the x and the y. Okay? So I will draw the way I like better to draw them. So 0, 1, 0, 1. And I have here 1, 1. Right? And this is my x, this is my y. Okay, I prefer this way of drawing. Okay, so look please now, I take the two adjacent ones. Listen to me very carefully. Okay, look, you start with the x. We always start with the first variable. I look at x first. Is x changing from here to here? Okay, what is x here in this cell? What is x, please? You look here. What is x?
1.
1. What about this cell? What is x?
1.
Also,
Also,
did x change? No.
No.
So I have an x. Okay, I want to look now at the y, please. What is y here?
0.
0. What is y here? You are looking here.
1.
1. So did y change? Yes.
Yes.
Y changes, I eliminate y. So what is my answer? My answer is f equals x. So what happened? I simplified the Boolean expression using the Karnaugh. Yes, please? Did you understand? I'll do another example. Or do you want me to repeat
yes.
this one?
Yes, please. Yes, please. Can you do another example, please?
Yes, I'll do another example. Okay, so check this now. So this is a totally different example, okay? I have x, y, and I am dividing my two variable Karnaugh into 0, 1, 0, 1, and I am filling my ones now here. Who can help? First tell me what is f. Who can tell me now? What is the original f?
Y.
Y.
Sorry?
Y.
No, tell me the original before you simplify it. I have two Minterms.
X bar.
X bar
It's
Y.
X bar Y.
Plus
Plus
XY.
XY.
I want to make sure that all of you understood how did we find this. If anyone did not understand how did we move from K-map to F expression, you tell me now, please. So I repeat this part. Did you all see it? How did I move from K-map to expression? Anyone did not understand? Okay, good. I want now
Yes.
to... Yes, please.
Can you repeat, please?
Yes, check please where do you have ones. You see here, you have your 1. You look at the x and the y of it. X is a 0, so it's x bar. Y is a 1, so it is y, x bar y. Another thing you could do, what Minterm is this? This is Minterm 0, Minterm 1. And when you write Minterm 1, it is 0, 1, yani x bar y. These are two ways of writing it. Did you get it? Yes, no?
Yes, I did.
If you
Thank
did,
you.
you tell me how did I get this one?
Okay, this one, x is 1 and y is 1, so it's xy.
Very good. Okay, now I want to use the K-map. I have two adjacent ones. I take these two adjacent ones and I check the x first. Who can help? X, check the x. X was 0 here and it became a 1 here, so I eliminate x. I look at the y now. Y, it was 1 here and remained 1 here unchanged, so I have a 1. So f will be equal to y. Okay? So this is how I use the K-map to optimize or to simplify my function. Did you understand the 2 by 2 variable? The 2 variable K-map? Okay? So we will move now to 3 variable K-map. Okay, I will also draw it. How many do I have? 8, right? How come I have 8? Because I have x here and yz here, and x could be either a 0 or a 1, and yz could be 0, 0, 0, 1. Please be careful. 1, 1, 1, 0. Okay, be careful to this. This is how we write the K-map. Okay, if you have 3 variables, you are going to have 2 to the power 3 equal to 8. You will have 8 combinations. In the 8 combinations, you place them x here and yz up. Okay, please tell me now, what is this cell?
0 M0.
It's M0.
It is M0, and actually it is 0, 0, 0. You agree? How about this cell, M5? How do you write it, please?
1 0 1.
It is 1, 0, 1. And this, please?
1 0.
110.
Did you get
110.
Okay, did you get it? And look here, please, also. M0 is 0, 0, 0, so it is x bar, y bar, z bar. Do you understand? And this is 1, 0, 1, and this is 1, 1, 1, this is 0, 1, 1, and so on. Okay? So this is how you create a 3 variable K-maps. Okay?
Yes, doctor, بس
Yes?
I have a question بس إنه ما خاصة بهولي وخاصة شوي بالقبل.
Okay.
بسأل هلا أم بعدين؟
Can you keep it till the end so we keep going with the
Okay.
recording? Okay? And you ask me.
Okay, sorry.
No problem. Okay, we continue. So maps, they use largely involves when you are entering data into your map, the target is actually to optimize or have less terms. How do you actually have less terms? When you try to check adjacent ones. I want very quickly to list how do we fill it, so please pay attention. It is 0, 1, 2, 3, 4, 5, 6, 7. If you do a mistake when filling the K-map, you will get wrong answers. Okay? Make sure you fill them right. So it is 0, 1, 2, 3. What happened here? Why do I have 2, 3? What do you think? Because when listing them, I have 0, 0, 0, 1, 1, 1, 1, 0. Okay, if I have 1, 0, 1, 1, I would have got here 2, 3, but no. I have 0, 1, 2, 3, 4, 5, 6,
Doctor, but
7.
why did I change it?
When creating the K-map, they followed the idea of a gray code. Gray code, only one bit changes from one to another. So I'll try to explain it to you very quickly. You go 0, 0, change one bit, it will become 0, 1. Change also one bit, it will become 1, 1. Now change one bit, it will become 1, 0. You notice this is the sequence. This is
Yes,
called
yes.
gray. It is called gray code. If you don't follow the gray code, it's going to be 0, 0, 0, 1. Here, from here to here, notice please, 1, 0. 2 bits changed. Did you see? The 0 became a 1 and the 1, so this is not allowed. We use the gray code bit for the K-map. Okay? So this is why they use 0, 0, 0, 1, 1, 1, 1, 0. So only one bit change. So I am allowed to eliminate later terms. Okay? Okay, I will start now. I need your help. I need to fill the F expression into the K-map. Who is helping? Yeah, Carmen, can you try? How did I fill it? I will start f of x, y, z. So I have 3 variables. How many combinations?
8.
8. So I need to fill now this K-map. So it's going to be x here and y, z here. So we need to fill 0, 1. Now 0, 0, 0, 1, 1, 0. Let me write it down. Okay. So you have a 0 here and a 1 here. 0, 0, 0, 1, 1, 1, and 1, 0. Right? Okay, so these are the cases that you have. Okay, fine. I want now to move from here to the K-map. I need your help, please. Okay, how did I fill it? This location is the 0, 1, 2, 3, right? So this
Yes.
2, where do I fill it, please?
At the end.
Oh, in the corner. You agree?
Yes.
And the 3 is here,
The
and the
4
4
down.
and the 5. These will be ones. You got the idea? So I check where do I have ones in my schema of Minterms, and I look at the K-map. But I have to repeat, when filling the K-map, you fill 0, 1, 2, 3. So 2 on the edge, on the corner. Okay? How about 3, 4, 6, 7? Who can help? Yes, Maverick, can you help? How do I fill from here to here?
Yes.
Yes, please.
Okay, so we have a 3, so it's the third one, and so we have a 1 and the third one, and we have a 4,
Yes.
so it's 1 and the like,
And 4.
yes, and we have a 6, so it's the last one.
Okay, so this has a 0 in it, so no. This has 6, it has a 1, 7 has a 1. So automatically these will be zeros, right? So I have 4 ones and 4 zeros. Okay.
Yes.
When combining squares, this will reduce the number of literals. So I will go over an example now, please. I will draw it myself, so we divide them one by one. Who is helping, please? How do I fill the K-map? I have 2, 3, 6, 7. Yes, please. Jad, can you help?
ايه اكيد مس. اوكي عندنا 2 يعني 0 1 بعدين عندك 2 3 بدي احط 2 على اخر واحد.
So 0, 1, 2, 3. You agree? Then what, please?
ايه صح. بعدين عندي 4 5 6 اخر وحده يلي تحت بدي احط 1 وبدي احط على السابعه اللي حدها 1 يعني على قد مثل هول كمان ايكوال تحت 1.
Okay,
Yes, that's
so
it.
these are my 4 minterms that have 1 in them. 2, 3, 6, 7. Now what? I take the 4 adjacent ones and I check where do I have changes in my x and yz. So this x is a 1, this is a 0, 1. We have here 0, 0, 0, 1, 1, 1, and 1, 0. You agree? Okay, so this is x, this is y, z. Who is helping? I want to check the 4 literals, please. Where is x changing in the 4? Is x changing in the 4? How do you answer this question? X was here a 0, here we made a 0, but here it became a 1. So x changed. I eliminate x. Who can tell me now what can I do with y?
I keep the Y. I eliminated the Z since Z is changing.
Answer me how, what do I do with the y first? Y. Y here is 1.
It remains 1.
It remained 1 unchanged, so I have a 1. Now tell me about the z. Z. Z, it was here 1.
It was really 1 and it changed على 0, so we eliminated.
We eliminate z. So what am I left with is only f, sorry, f
Doctor, I have a question.
to y. Yes.
اوكي نحن كيف انا بقرر اذا بمشي اذا بدك بالطول ولا بمشي بالعرض وقت انا عم بشوف انه شو في قصص adjacent.
The adjacent. Yes, exactly. The adjacent squares could be 1, 2, 4, 8. So this is how you go. Okay? I repeat, you could take 1 adjacent, 2 adjacents, 4 adjacents, or 8. So here you look. Do you have 8 adjacent? No. Do you have 4 adjacent? Yes, you take them. Okay?
Yes, we have 4.
You don't take.
دكتور يمكن الكونكشن عندي مش منيح. مش عم ببين أي شيء عم بتأشر عليه على هذا
Okay,
على
I will repeat. Okay. You have 4 adjacent squares here, 4 adjacent. The first thing you should look at, do I have 8 adjacent ones? Do I have 8? No.
No,
Do
I
I have
don't.
4? Yes, I take 4.
Yes.
You don't take 2 if you have 4. You try to take the biggest adjacent set of squares. You don't take 2 if you have 4. Okay, it will be wrong. You try to take the biggest adjacent that you have. Okay? But you should think
Okay, so
finally.
can we do it one more time? Can we just like do it again so we can find y?
Okay, so here you look at the x. X was here 0. It became here 1. So x changed, I eliminate x. I look at the y now. Y here is 1 and here it is 1. So 1 did not change from here, this column, to this column. So I have y. I look at the z now. Z was 1, it became 0. So z changed from this column to this column. I eliminate z, so I am left with f equal to y. Okay?
Thank you.
Okay, we move to now 3 variable K-maps. What they are trying to explain here is to tell you what happened from 0, 0, 0, 1, 1, 1, 1, 0. They are trying to tell you that you can take adjacent because you assume the K-map, if you roll it, it will look like a cylinder and you can take the edges as adjacent also. So I will try to explain this in details when drawing, so check this please. This is a K-map of 3 variables. I have a 1 here and a 1 here. What I'm trying to say, imagine this on a paper and you roll it and this one become adjacent to this one. You got the idea? What do I mean by roll the paper? So now, yes, I can take the Minterm 0 with the Minterm 2. You see? Minterm 0 with the Minterm 2. I can take the Minterm 4 with the Minterm 6. You got the idea? So these are considered adjacent. Not only they have to be adjacent in the middle, the edges are also adjacent. You have to keep in mind that K-maps, they could be rolled. When you roll them, the edges become adjacent, no? Imagine having a paper and you roll it. Okay? So they become also adjacent. Okay? So having these minterms, if you take the Venn diagram, if you want to take the adjacent, let's say you have here a 1 and here a 1. What do you do, guys? Which squares do you take? Yes, please? If you have 4, you take these 2 with these 2. So now I have 4 adjacent, and you take them as 1 minterm. You got the idea? So the edges now are considered to be adjacent. Okay? I want you to look, please, carefully. I am trying to give you examples of shapes that you could take. So please follow. This is a shape. Okay? Rabia, are you following?
Yes, I am. Yes.
Be careful. This is another shape. You could take the edges. You could take these 4, the edges 4. Okay? I need your help now. What can I take as adjacent? Yes, please.
middle square.
الفور سكويرز يلي بالنص.
Now, I need to cover as a rule all the ones. All the ones must be covered. Okay, I covered the middle 4. Did I cover the one on the corner?
No.
No. So I have to take it.
بدي
I
تكون
take
معي لحتى.
Exactly. This is my next question. Do I take it alone or do I take it next to the adjacent one next to it?
Next to adjacent one.
على adjacent one.
Even though already the one in the middle was taken, you can take it again, no problem. Question. How come I did not take the 3 together?
The edges are not adjacent.
No, حد بعضهم. Check, they are adjacent.
لأنه y is not included بالهو.
No, that's not the answer.
يكونوا even answers يعني 4 أو 2.
They should be 1.
عندنا بس في يكون عندنا
Okay, so 3 is not here. It's not an option. It's not a binary multiple of 2. Okay, you got the answer. So you could take 1, 2, 4, 8. Okay, so this is how you do it. Oh, very quickly, please. Let me try to simplify this. So 1, 1, and 1, 0. I am looking at the 4. Who can help? Yes, Carmen, can you? 0 is changing. So x is changing. I don't have an x. Yes, please.
Right. So y
Y is changing. I don't have a y. And z is not
Yes.
changing. I have a z. So this is my z. Plus, I am looking now at the second minterm. X is 0 in the 2, so I have an x bar. And y did not change, so I have x bar y. So this is my answer. Okay?
Miss, I did not understand. بس فينا please نعيدها please على بعض.
Take these 4. Okay? And you check x changed, so I don't have an x. Y changed, I don't have a y. Z remained 1, so I have a z. So this is why I have the z. Then take these 2, okay, where you have x did not change. It was 0, it remained a 0. So this is your 0, it remained a 0. So this is why I have an x bar. Y, it was a 1, it remained a 1, so I have a y. Okay, and the z, it was a 1, it became
Is that changed?
so I don't have it.
Okay, perfect.
Okay, so this will give you the simplified version of the function.